point. Thanks everyone for coming. I know afternoons are a little bit hard, but this was one of the few times we could fit in this class into the busy schedule everybody already has anyway. So welcome. Just so you know, I have taught R before, but not a full class. Some of you may have seen me give a workshop or like a video recording of me giving an R workshop through the OCTRI BIRD program with Dr. Niederhausen, Micah. And so we've done a lot of little mini workshops. I've given workshops at other places, different conferences, but this is the first time I've taught like a full, 11-week class. So it's a lot. We're gonna go through a lot, and definitely let me know how it's going throughout the class, and we'll have ways for you to give feedback and kind of shape the way this class goes and towards the end. I will say that I am a statistician. I am not a programmer. I took programming classes in college, but that's about it. So if I say anything that's not programming lingo correct, sorry, but I kind of, it's the joys of being a statistician. We have to program, but maybe we don't have all of those tools in our toolbox. And that, I think, is why you all are here, because I know in classes you may have used R, but actually sitting down and learning how to do R, how to code in R, and how to be an efficient programmer can take a lot of time and a lot of struggle. So we're all in it together for sure. And so these slides are on the website, which the link is now on Sakai, and I'll show the link in a bit. You can see it here. So you can pull up these slides if you like, but you'll be able to find them easily after class as well. And so within these slides are links. So these are links to our workshops that I was talking about. There are recordings if you want kind of extra learning. Feel free to peruse that. And also in my real job, I mostly do research. All of us at the School of Public Health are mostly researchers. And so one of my big roles is in the Cancer Institute. I do a lot of collaborative work with people who do cancer research, as well as cardiovascular research. So that's kind of what I do as a statistician. And I've been at OHSU, I think like 7 years, 6 years, I don't know, a long time now. And also this class has a TA, Colin. Colin, do you want to introduce yourself briefly?
Yeah, for sure. So my name is Colin Hawkinson. I am a second-year epidemiology MPH student. I didn't take any coding in undergrad, but I've been working in a biophysics lab at the University of Oregon since I graduated from Reed, and I've learned a lot of good skills on the job in Python and R. I've built a couple computer vision little applets. Yeah, that's me.
Awesome. Thanks. I'm excited that we have someone that is an expert already from taking last year's class. And so Colin will be helping us with some grading and also questions. So you'll see the forums where we can ask questions, and Colin will be able to answer some of them as well. So just so you know, we're going to go, the first bit of this class is going to be just kind of introduction to how this class is going to work and some logistical stuff. And then we'll get into our coding. So just in case it wasn't clear from all of my messages I've been sending out, this is a pretty new course. I think we've had the idea to have a course like this for a long time, and we finally were able to develop something. Last year was taught by Ted Ladaris, who was in the DMICE, Department of Medical Informatics and Clinical Epidemiology, and Ted mostly developed all of these materials. I helped him a little bit, but Ted is kind of a superstar in terms of developing educational materials. So most of this success of this course goes to him. He worked really hard in coming up with all these materials and putting them out there for everyone to use. And so I've edited them a little bit based on feedback, and I'm still working on editing some later weeks, and I kind of want to see how the first couple weeks go. But you can see all of the old materials and all of the old videos of the recording of the classes on last year's website. which looks very similar to this year's website. And so I'm going to model this class after what he built. Ted has left OHSU, so I was supposed to teach it with him last year, but I went on family leave, and then now this year, tables have turned, I guess. Now it's my turn. I get to do it all by myself. So he now works in Stray and is teaching there. So the one thing about this course is that it was, you noticed through registration that it was kind of blocked onto biostat students. But I imagined when we developed this course that it would be more open to people at SBH and also outside of SBH. And we actually luckily have some of you are not biostat people. Some of you are other departments and other programs. So I think that's really exciting. R is not just a statistician language. Lots of people use R. And the other thing about this is that I know a lot of you have had R, based on the survey, have had R before in a class. And whether that means you had occasional homeworks and you had to kind of manage your way through R, or whether every homework in that class was done in R, I think that means that we're going to have a wide variety of experience levels. And that came through in the survey as well. I think most of you have had a little exposure to R, which is good. But in the beginning, I'm going to start with the assumption that you don't have that much R experience. And so for some of you, maybe most of you, the first couple of weeks are going to be kind of slow, maybe boring. But I'm going to try to kind of pepper in some other more advanced tips throughout the way, so to like keep you on your toes. But if you feel like it's just too slow, feel free to not show up and just watch as much of the recording as you want. I don't want to waste your time if you feel like you already know everything that we're going to talk about. But I do want to not just kind of zoom ahead and assume that everyone knows everything. So we're going to take it slow in the beginning and then learn some more intermediate topics starting like week 3 or 4, probably week 3, just so you know. And so of course, this virtual learning, I had imagined that by now, of course, we all did, that this would be in person. It's not. We're all on the computer. It's hard to learn coding on the computer. It's hard to teach it on the computer. So I want this to be a safe space. Don't feel like you need to know everything. Coding is weird in that you can think you know something, but then get a strange error and you can't interpret it at all. And so we're all going through that. And I think it's got to be a place that everyone should feel comfortable asking questions. So don't, if anything makes you feel like it's not a good space to ask questions, let me know. I think that you could learn R just by watching videos online. And the reason you're in this class is because you want to learn from me by asking questions. You want to learn from each other. You want to learn from our TA. I think that's the really useful part of this class. So let's make the most of that. And so Ted always has a code of conduct, and I love that. I copied it and also added the OHSU code of conduct because we all should be abiding by that as well. So let me know if you feel any part of these code of conducts are violated. We want this to be an encouraging place to learn. There is a little form if you want an anonymous reporting about that. There's a form you can fill out. It's just a Google form, and we will take care of that. The other thing is that I'm using Zoom. I think probably most of your other classes, if you're at OHSU, are with WebEx. I take to Zoom because I want to try using breakout rooms, and it's a little bit easier. But for those of you who haven't used Zoom before, I feel like that's probably extremely unlikely at this point in the pandemic life, but just this very quick tour of Zoom. You can show your video if you like. You don't have to. I like seeing you, but you don't have, if you want to, for your privacy, you don't have to do that. Like I said, if you want your name to be changed, there's some instructions on how to do that. I think you can also click on your name and your video, and yeah, you can and rename yourself. So if you want to be called something else, you can do that. So when we're going through class, we're going to actually go through some exercises. And it's kind of useful for me if you can use the reactions to tell me that you're done. And I just hid my controls, so now I can't even find that. Here we go. So there should be a little on the bottom of your screen, or depending on how you're using Zoom, there should be a little button that says reactions, and then you can do like hands up to indicate that you're finished. So try out that. We'll see how it goes throughout class. And if you can't figure that out, message me or chat me and we can figure it out together. And the other thing is chat. If you have a question, feel free to ask it in the chat. So if everyone could, someone gave me a football sign, nice. So if everyone could just maybe write their name in your program and maybe one thing you want to learn from the course is kind of a little icebreaker, that would be useful. Make sure you send it to everyone, not just me. And so I have so many screens, it's kind of hard for me to see the chat when I'm talking, but Colin can monitor the chat and let me know if it has a question, or you can also just unmute yourself and let me know if you have a question throughout class. Yeah, great. So we do have students in outside of SBH. We have a couple, I think 3, the first 2 to respond. We have cancer biology, we have social work, and I think that is awesome. But then we have a lot of biostats people. I think it was like 13 out of 19 people are biostats people, which is awesome. Cool. Awesome. And yes, streamlining code. I think that's going to be a big benefit. I know if you've used R in a class and you just kind of copy and paste those examples and not really know how to adapt that can be really frustrating. So I think being able to be efficient, write some functions and be more comfortable. That I think is my goal. And visualization, that is also fun. So I'll try to cover these things. Some of the more like bioconductor, maybe we'll see about that, if we can get to something like that. There's a lot of kind of advanced topics. There's like too many advanced topics to choose from, really. We need a full year-long course for everything. Great. Well, nice to meet you all. I wish we were in person, but we are not. Oh yeah, so like I was saying, chat is a good way to ask questions. I'll try to look at it periodically. And so this is during class. Colin will let me know if there are questions in the chat, or you can interrupt me by unmuting. And then outside of class, okay, and during class, I forgot about this part. So the other part about class is that if we are working on kind of a long lab section where I want you to work on something on your own, I'm going to try to use breakout rooms to put you in little mini rooms where you have maybe 3 people and you can work on that together. Because I think one major way of learning is to learn from each other and see how you kind of, I don't want to say struggle, but you know, things can be hard, and working on them together and figuring it out and getting errors and coding together is an extremely good learning experience. And then you can share your screens and talk about things without the pressure of 20 people listening to you. I don't think we're going to do that today because I didn't really include that many difficult problems yet, but once we start getting into more complicated tasks, we will do that. And you can share your screen in a breakout room as well. And you should have the option to share screen. I think I turned that on for everyone. If you don't see it, let me know. Even if you can't see it now, you should be able to see it in your breakout room as well. You might not be able to see it because I'm sharing screen. I think I'd have to turn it off for some of you to share your screen. And so I think the one thing I wanted to do was try breakout rooms, because I haven't done it with this many people before. And so let me try and assign people to a breakout room. And for 3 minutes, so we'll come back at like 3:36. You'll about 3 people in your room. Let me see. I'll do 6 breakout rooms, I guess. And so share what your favorite all-purpose condiment is, if you have one. If you don't, you can say that too. And I'm going to see what happens when I assign it automatically. It's a test. We should have, how many people do we have now? We have 20 people, and Colin and I are 2 of them. So I'll do 6 breakout rooms. And
Jessica, you might have to pull yourself and Colin out of that group of random assignment.
I was wondering that. Thank you. Oh, yeah. Wait, Colin is in room. Well, let me see. That's okay. Colin can be one. One of you is going to have 4 rooms. All right, I'm going to open the rooms, and you should get a little pop-up that says go there. And they're all disappearing. Zoom recording, which is going to be hard for me, but I'm going to try. All right, hopefully you all learned something, or it's probably too quick to learn too much about yourself. I think my favorite all-purpose condiment's probably salsa, but sometimes I don't want spicy things, so depends. So I think we're going to try that with harder questions, probably not today, but probably starting next week. Hopefully 3 people is like kind of a good number for coding together. And you can always sort of bow out of the breakout room if you need a break. So in terms of recording, and we'll talk about what kind of constitutes the grade in this class. This will be recorded, and then we'll post it as soon as it's ready. They've actually been ready quite quickly, so that'll be hopefully like by the next day. I'll try to pause during breakout room times, and I will try to remember to restart. If I haven't restarted or started when the class starts, please remind me, because I can be forgetful about that. And in terms of learning objectives, I think there's kind of broken up into 2 parts, this class. I think the main part of the beginning is going to be data, kind of how do we get data in R, what are efficient ways of dealing with data, and a little bit with ggplot, which is a visualization package. There's also going to be a lot about kind of what we think of as data wrangling, data cleaning, data munging, whatever that means. I think that's, as a statistician, that's like what you don't tend to learn. And as a non-statistician, as a scientist, it's also really important. All of us probably have seen data by this point in our studies or our career, and we know that it can be hard to deal with. And so I think all of those kind of tasks and doing them more efficiently with automation is going to be what I'm going to focus on. If we have time, we might get to more advanced topics. And I want you to kind of tell me what you would think is most important. Last year, I think they talked about tidy models, and I think talked about some website development. I don't actually use tidy models, so I'm a little nervous to teach that, and I'm thinking of replacing it with some other stuff. And I actually have a survey up in Slack, which you can contribute to or add stuff to. I'll show you that in a minute. But I think this course could go many different ways, but I want it to be something that's useful for everyone, so, or at least the majority of people. So let me know what you think after a few weeks. So one thing I want to pause and say that programming is hard, especially for people who haven't had a programming class, but I think everyone can do it. It's not something that you need to have like a mental block against. I think that it just takes time, and It can be very frustrating, and it can feel like you can't get anything to work. But if you ask questions and try, I think you can all get there. There's a good, Ted had this good quote on the website. It's kind of like learning a new language. And so you might get really frustrated and think that you're not up for it, but everyone gets frustrated. I think even people who have been coding for many, many years can get frustrated. So don't blame yourself. Take a break, do something fun, and come back and try again later. And there's a funny little comic here that shows this crocodile getting very frustrated, errors all around. Maybe it's a bug, I can't do it. And then they walk away, and the flamingo finds that it's just a spelling error. Half the time it's like a spelling error or an extra colon or something. So take a break and maybe try and read the code to someone else. That's always a good way to get back to things working again. And as far as logistics, so let's go to actual website. I sent this to you all. This is where the slides are going to be for every class day. You can find that in classes. There is a syllabus up here. There's also a syllabus in Sakai. There's a schedule, which has a general plan for what we're going to talk about. But the classes page is going to be the most important, because for class 1 right now, there's some instructions on how to install R in Rstudio if you haven't done that already. There's a folder link that has this class's kind of lab markdown component in it, and I'll show you that in a bit. It has the slides we're talking about, so this is the link to the slides. I'm also going to talk about for loops for a minute. And you can go to last year's website and look at the video from last year if you feel like really hammering things in. And then we're going to talk about this in a bit, but there's going to be a post-class survey. And so you'll have that link there as well, though it's always the same link. So it should be easy to find. And so this website looks almost exactly like last year's website. So I added a 2022 just to kind of avoid confusion. And we'll also be adding some other options up here as the class goes along. So we'll use this to post videos and other information. There's also a reading section. So for first class, I had just a few kind of basic R reading. So if you have a chance to do that this week, this will really help you kind of accentuate what we learn today about data frames and vector. Well, next week we'll do data frames, but this week we're doing vectors and Rstudio projects, and a few basics about R in Rstudio that are useful. But there's also going to be other kind of references in here that will be useful to you if you wish to go through them. So we'll go through a couple slides and I'll see if we have questions. I do want to mention that this is not a conventional programming course. We're going to treat it like we are just trying to learn some more R, where we want to learn some interesting and useful things from the beginning, not right into the nitty-gritty of how the programming language works, but just how to use it well. And I'm going to focus on using what we call the tidyverse. We'll explain what that means, but basically it's kind of a philosophy in a suite of packages that helps, I think, new and experienced users get up and running quickly. So you'll see that in action next week. And it's also not a full course on statistics or machine learning. I do want to touch on how to run some models, but I'm not going to explain the background of the models. That's kind of what your applied biostats classes are for. And if some of you are in, I think there's a machine learning class on right now, data learning. So maybe you are learning that alongside this class. And there's no official textbook either, but there are so many textbooks online, so many now related to R and data science. These are some very good ones. I think this one and these bottom three, I think, are actual books. Like you can buy them as printed books if you would like, but they're all freely available online at these links, so you don't really need to. and it's a little easier to search them that way anyway. And so this is Dr. Ladaris's approach to teaching. It's also my approach. I think that it's most useful to be in the data, looking at it and working with it while you're learning. So that may mean that things go a little bit quickly because we're going to be live coding. But that's why I want you to ask questions and stop me and make me slow down. That is really important. So I think this will be a good learning experience if even if you can't keep up during class. Another reason why they're recorded, you can always go back and rewatch a segment if you missed something. And the other thing about the breakout rooms, I think social learning is important, learning with each other. It's something that's really hard to do virtually, and we'll try. I don't know. It would be way easier if you were sitting next to each other in a room, but we're not, unfortunately. And I'm just going to randomly assign the breakout rooms each week to kind of mix them up. It's not like you'll always be with the same people. Okay, before we get to this part, are there any questions? I've just been talking at you for a really long time.
Just mentioned there was a poll in Slack and I didn't see one there.
Yes, I'm going to have a little preview of Slack and I'll go to that in about a few minutes. Yeah, good question. Anyone else? Are there a lot of similarities between R and other languages? Yes. Like Python. Yes. I'll talk a bit about R when we like open Rstudio. I learned C++, I think, and Java or something back in the day when I was learning programming languages. Those feel very different to me, but they're not really, because R has components of those languages as well. Python and R, I think, are the most similar to each other because Python is a real programming language. You can do all kinds of things in it that you would do with C or C++ or Java. Python, I never actually learned, but I feel like I have like a reading comprehension of it. I know how to do some things in it by necessity, but I never formally learned it. And just looking at it, I can tell that a lot of the way that it is set up is similar to R. And R and Python have modules or packages or whatever you call them, components that are built to work with data. So that's what sets it apart from other kind of more straightforward regular programming languages. Yeah, that's a good question. I took a programming class in grad school and I guess we learned a little Python. It was more of like a variety pack. We learned some components of different languages and that was fine, but I feel like I didn't really get a good grasp of any one of them. So it's kind of nice that you get an R course by itself. Yeah. Okay, and I will try to have breaks probably around 4. Oh yeah, the slide says that. So the format of the class, not today, but next week, we will start this. So there is a post-class survey, which I will show you in a few minutes. And that asks what were the muddiest points? What were the points that you were confused about? And so we're gonna go over those each time. And then starting in week 3, we're gonna have function of the week presentations, depending on how many people sign up that week. And I will talk more about that next week, but basically the idea, Ted instituted this as well. The idea is that you will each pick a function to do, excuse me, a very short presentation, like 5 minutes max, about what that function does. And there will be a sign-up sheet. I haven't finished the sign-up sheet because I wanted to change it from last year. But you can see, let me see if I can, this is this year's, last year's. Okay, this is last year's website, and you can see everyone's function of the week assignment from last year. So you can get an idea of what people presented on. And I will talk about all the details, how to sign up next week. Hopefully I'll have it done. So don't worry about that for now, but it will be something that's part of what we do today in class. So hopefully a chance to learn a little bit more from each other. And then I'll have a couple hours of R in our markdown files within RStudio. And then we'll have some questions at the end. So that's the general way that we'll have class. I won't be yammering on in the beginning about all this stuff so much. Mostly will be R. And we'll take 5-minute breaks, hopefully, if I remember, at the top of the hour. And the syllabus is on the website, as I showed you. There's a syllabus section, but it's also on Sakai. And so let me know if anything's confusing or you have noticed discrepancies between the two. I tried to make sure they were the same, mostly on the important parts. And the important thing I think that everyone wonders about is, what is the grading breakdown? So the question, sorry, I'm not used to talking this much for this long. So the question about attendance, I'll take a 1 second break. So attendance is part of the grade, but I will say that I don't really mean that you have to come here and be present, though I do think that it is useful because, like I said, you could learn R by watching videos. There's so many videos online. This whole class is online from last year. But I think the reason you all signed up is that you want to be engaged and talk to me or fellow students. And so the attendance part is really just, are you there if you can be? It's not that important. Okay, if you need a break, this is crazy COVID pandemic times. I don't think we all should be expected to be on 100%. And so if you need to, just watch the recording. You can watch the recording at like 5 times speed and skip around if you want. I don't care. I just want you to be able to like feel like you got something out of the class. So attendance is actually just going to be marked by a survey that you can take after watching the being here or watching the recording, either way. And I will show you that link. So that's part of it. We also have a midterm project, and I'll talk more about that later. Basically an analysis, kind of an analysis project or a visualization, more of an exploratory project for the midterm. The function of the week assignment, which again, I'll talk about next week. And then each week we'll have homework assignments, which will be, I'll give you an R Markdown file. I'll talk about what an R Markdown file is. And then you will upload the kind of completed rendered HTML file to Sakai. And so we'll have one each week that's due the following week until like the end of that Wednesday, 11:55, I think is the cutoff on Sakai. And then a final project also kind of similar to the midterm, but I think last year it was more analysis based. And we'll kind of see what we do towards later assignments, but I think that's the format this year as well. Any questions about that? Cool. All right, well, let me know if you do. And like I said, this is what I was talking about in terms of attendance. So the way we're going to check attendance is there's this form down here. I'll click on this. It's just a Google form. Name and email. So give me your name and email if you've watched, let's say you watched this first one, you're here, or you watched the recording. But then when I pull the data out of this, I'm separating the name and email and date. Well, I'm separating the name and email from the other results. So there's also a survey component that essentially is anonymous. I won't link them. I won't look at who wrote what. Technically I could, but like on my Word, I won't look at who said what. And so I'll pull out the date. Let's say you're commenting on the first one. I'm going to ask you, all of these are optional except for the first 3 questions, but I'll ask you, was the class too fast, too slow? You can give a rating on that. And the main question is, were things clear? Were things unclear? And if there's anything else you'd like me to know. And so I completely stole this from Ted because these were the exact same questions he asked. And I liked it because you can see, if we look at the old class, where I keep losing. Last year's class, you can look at the bottom of each class, you can see what people said were not clear and what worked for them. And so I'm taking last year's feedback into account. I added a little bit more about for loops. We'll see if we get there. We'll get there next week if we don't. And just kind of seeing what works and what doesn't work, I think is really useful. So obviously these are optional, but I would really appreciate it if you could fill some of these out for most of the classes. That would be wonderful. And anything you'd like me to know, just this is sort of like a letter to me telling me what you'd like me to change or just thoughts that you have about anything really. So the link will always be the same. You just pick the class that you're commenting on. And then I will use this part of the form to count attendance and this part of the form as kind of a feedback situation. And assignments, like I said, will be our Markdown. You can submit them through Sakai. If you can't get your Markdown to load or render or whatever, just send the Markdown document, that's okay. We'll take that into account and then we'll try to grade it and return it as soon as possible. And then I will go over some confusing parts if I need to during class. This first week's assignment is pretty short. I think most of them will probably be pretty short. We'll see. But let me know how that's going as well. And like I said, function of the week, I'm going to talk a little bit more about that next week and show you the sign up sheet. But I think this is going to be a useful way to kind of, it's like a me project, but it should be really short, 5-minute max presentation at the beginning of class. And just kind of your experience learning about an R function. And if you want, you don't have to, but you can definitely meet with me to talk about it before you present. Happy to do that. Midterm is all about analyzing data. When we get closer to that, we will talk more about it. You can actually see, I'm trying to go back to last year's website. You can actually see last year's midterm projects, which is really neat. I really like looking at these. So these are fun to look at. Obviously, I will ask you if it's okay to put it up on a website first, but all these people consented and you can look at all the data analyses that they did, which is really neat. Based on data that's just publicly available. And for both, I think it'll be useful to meet with me quickly to kind of let me know what data you're thinking about and what you plan to do, just so I can make sure that you haven't like picked something really difficult that's you're gonna regret later, basically. And so Slack. So Joseph was asking about and if you know the answer, try to answer questions. That I think don't be afraid of being wrong. You should definitely try and help other people. I think that's really useful. You can also like have video chats in there with each other if you want. I haven't really done that much, but I know it is possible. And then in terms of office hours, I don't know. We'll see how this goes. For my virtual classes, I find that people don't use office hours that often. They mostly just want to request like a one-on-one time with me, which is okay. So on Sakai, I have when is good survey, kind of getting a sense of what times you all are available. Right now, I think it was like Wednesday mid-morning or right before lunch, or Friday mid-morning, we're good for a good amount of people. So I might start out with like an hour of office hours, see if anybody uses it, and change it up throughout the quarter. I'm not sure yet. Also have a link where you can like request a meeting with me. I made it in 15-minute increments. If you want, it's sort of short, but if you want like a 30-minute meeting, you can make 2 appointments just to kind of avoid the whole like back and forth with scheduling times, which can be a lot. So try that. Email me or Slack message me if none of this is working for you. I'm happy to meet outside of office hours or other times. And I'll try to be on the Slack channel answering questions as well. Okay, I said we'd have a break at 4. Yes, let's have a break now. So let's come back at like 4:07 in 5 minutes. And then we will almost ready to start just a couple more slides of intro stuff. All right, I think it's about time to get back. I definitely want to move over to R soon because I'm getting tired of talking about intro stuff. But now we can start thinking about what do we learn? What are we learning? So someone asked, is there a difference between R and other programming languages? And R is really known for its kind of ease of use in statistical modeling or machine learning and data science and working with data. That's kind of why it was developed. It makes really nice visualizations and that is a lot of its strengths, but it also is what we might think of as like a hub language where you can actually access many other different kinds of systems, like TensorFlow, databases, Apache Spark. Another example might be like HTML, CSS, all of these slides I wrote in R. Now it's showing up on the internet as like HTML rendered slides, right? So all kinds of things you can do with R. And you don't need to know other languages if you don't want to. You can also kind of speak to other languages, like you can invoke C, you can invoke Python. If you know Python, you probably know that you can use R within Python as well. They kind of go back and forth. There are ways to do what you want in whatever language you want, basically. And so that's why it's really been embraced by the statistical community. You can develop your own packages and create functions that do some kind of fancy modeling that you developed pretty easily and get that out there in the world. It's open source, it's free, it's very powerful. It's a lot more like a regular programming language than, say, SAS, which is not like a regular programming language at all, or Stata. Stata is kind of in the middle between SAS and R, I think. And so it's just a lot more flexible than other languages that, not necessarily languages, but other statistical programming softwares, I'll say that. Like there are, SPSS and JUMP and those kind of drop down software that will do very fixed, limited number of things. Whereas R, it's infinite what you can do in terms of statistical modeling. Which makes it really powerful and useful. And I will say that R is not easy. If you've already struggled with R, you already know this. It can be difficult. It can be an upward battle. But we're going to try to make it fun. It can do a lot of fun things. And once you get a little more comfortable with it, it can feel a lot more accessible. So you'll get there eventually. I will also say if you have taken programming courses and maybe you do know Python or another language, R might seem weird and frustrating in the way that it does certain things. So you kind of just have to let that go. It has its weird quirks. People are trying to overcome them. The people who developed Tidyverse are trying to overcome the weird quirks, which is another reason why we use that. But we can't really get over some of the things that it does. It just does it because of how it was developed. So there are some oddities, I will say. But in general, it is a really fun language to use and very powerful. One note is that last year they used what's called Rstudio Cloud, which uses R in the cloud. And that means that everyone's setup was exactly the same. But this year, for various reasons, and I know a lot of you have already used R in Rstudio, so hopefully this is okay, that we're just going to try to use our own computers. So I will note that there is kind of a cloud environment through PSU if you have PSU login, which if you are a SBH student, you should. Obviously our PSU students do, that you can use on there. But then you have to figure out how to get the data in and get the files in and files out. And so that whole kind of back and forth thing I wanted to avoid. But you are able to do that, and I'm happy to support you doing it that way if it works for you. And if you are unable to install a certain package or get something to work on your own Rstudio setup, just let me know through Slack, and we can try and troubleshoot together. Hopefully enough of you have used Rstudio and R that it's not going to be too challenging. and we'll see how it goes. I may regret it later. I don't know. We'll find out. I just have some other resources here. There's so many resources, but these are our local resources. There are our workshops. We haven't had one in a while through OCTRI Bird group, mostly because Micah and I have opposite teaching schedules now. So we'll see how that goes. Hopefully maybe in the spring we'll have another one. And there is a local Portland R user group, which I used to go to all the time, but I haven't lately. They're doing virtual meeting times, so that's a fun group. They're all really friendly. People give presentations on what they're doing in their R world. A lot of people from industry go. It's really neat to see what non-academic statisticians do with R. I think that's the coolest thing. And actually at OHSU, we have a biodata club. I'm going to click on this one. You can sign up for their mailing list somewhere down here. I don't know where. I think you have to click on something. They have a Slack channel that you can join as well. And this is a fun group that's mostly non-statisticians. It's actually a lot of biologists and kind of more informatics people. And I really like going to these because they have kind of little workshops, very short hour workshops usually, learning a lot of different fun data science topics. So I really encourage people to join this. They haven't been super active this year. I think virtual learning is hard and all of that, but if you can get hooked into that group, I definitely recommend that. And there's also a local R conference and they have workshops. I was one of the founding members who we organized the very first one. I think they're on like year 4 or 5 now. They were going to have that in person, but I think they decided to do a virtual conference again this year. So keep an eye out for that. I'll probably send the message when they have the program up. That is also really interesting conference to attend. And cheap, really cheap for students. Okay, I think we're done with slides. Any questions? Are we bored? Probably. Let me, since there's no questions, and I lost my folder. Okay, so what I'm gonna do is open R. I send all of you a Dropbox link, and I also put it on Sakai, which should have pointed you to a Dropbox folder that looks like this, but on the internet. So it's a folder called SPHR Programming Class Project Folders. It's called that because I have a lot of folders for this course now. But this one is going to have one for each class. Right now there's just class 1, part 1. We'll see how much we get through this. This might roll over to next class. I don't want us to feel like we have to finish everything. And sometimes we'll end early, but you should have all of these files. And I also have a little video on like unzipping and opening this folder. So if anyone has had trouble with this, maybe let me know during break or on Slack and we can try and figure it out. But what you should have seen once you downloaded this folder to wherever you put it is a set of files. I actually did update this file, just so you know, yesterday. So you might not have the most recent version. Don't worry about that. You can download it again. You have most of it, 99% of it, so that's okay. But what you want to do is open Rstudio, which you should have installed hopefully by now. If not, again, let me know. By opening this project folder, file. So this is going to be called something different possibly for each class, but it's always going to have this .rproj ending. So I'm going to double click on this and it's going to open Rstudio. And I opened it over here. And what? Trying to make this fit here. So the one of the many hard things about virtual learning is I can never be sure how big to make the font, because you all have different size computers. If anyone's having a really hard time seeing this, let me know. I don't know why this came back over here. And this is what my Rstudio looks like. I have a very strong feeling that yours is not like this. I believe I changed my panels. I changed the lookout. I changed probably the colors and the font. I definitely know I tried to change the font. So don't worry about that. but you should, and actually probably it looks more like this. If you've opened up that R project file, it probably looks like 3 panels, probably in a different order. So what I want you to do is find the panel that has the names of the files. You might need to move around this little bar. See, there's a little movable window here, and find the file that says part1.rmd and just click on that. And that is going to open a new file for you. And before I do anything, let me hide these controls. I'm going to copy this. So I'm going to do File, Save As, and I'm just going to rename it because I might edit some things. So it's a good idea to just make a copy, call it, maybe put your last name at the end. Make sure you're putting it in the same folder that has all that other stuff in it, and press save. So now this is part1 mini-a.rmd. And so this is what we're going to be working on each time. And this all of this looks like our code, but you can make it look nicer, and I'll show you what happens. But this is where all of the work is going to be done. So before you get started, save this as something else, first name, last name, whatever you want to call it, just so you have a copy of the original in case you accidentally mess something up, as I might do. And just a note to say that the first time you're doing something, it's a good idea to actually type it out and not just copy and paste, because then you can slow down and see what the code is doing. But during class, that can be really hard to do. It can be hard to keep up. So do what you need to do. You don't even have to code along with me if you don't want to. Just listen, whatever works for you. But definitely slow me down if I'm going way too quickly. And I'll talk a bit more about what these windows are in a minute. But like I said, just looking at this, making sure, comment in the chat if you can't see my screen very well. I'm hoping it's big enough. This course, like I said, we're going to talk about common tasks in data science, importing, wrangling, visualizing, modeling data, and then get to more advanced topics like some more complicated merging data, joining tables, filtering tables. But yeah, I'll answer that question in a sec. And more fun things like possibly getting to more advanced R Markdown, maybe Shiny. Some of these things you probably don't know what they are. And as we get later in the class, I will talk a little bit about them to see if there's interest. And we will talk about mostly the idea of reproducibility and how to make our workflows more efficient and reproducible. That's something that is important to me, and I think should be important to people who do data work and science for that matter. Okay, so we already covered this in the mini slides. So in terms of R and RStudio, a lot of you said that you have RStudio already installed. That's wonderful. Maybe you don't feel so complicated or comfortable with it. One question was, they updated R. Is this the right way to open? Is that to make sure it's using the right version? So one thing to note, just looking at your screens, depending on where your panels are, you should have one that's called the console. And so this you can think of as like your live coding, testing things. I can type in here and press enter, and it's going to run things. And this is where a lot of my output is going to show up. It also tells me what my R version is. I updated my R so that I think this is the most recent version. You can see if it's above like 4.0, that's great. That's pretty close. If it's less than 4.0, I would recommend updating R, which just means going to the R website and reinstalling R. You don't even have to open R after that. RStudio will just automatically pick up the newest version. It also says it here at the top of your console. So that's one thing to know. The other thing is what's going on over here. So this is the kind of script file writing area. I don't even know what to call it. So this is the console window on the left. Hopefully you can see my cursor waving around. This is where we write our code, where we're writing files. We're going to have markdown files here. I'll explain that. You should have another window. Mostly we'll look at the environment tab in this window. Right now it's empty. We haven't run anything. And then we also have the files, but this little panel is actually useful because this is where it's going to show your plot sometimes, and there's a help section, which I will show you in a little bit. One thing, so I mentioned that I have customized my RStudio. So for those of you who have used RStudio before, maybe you haven't really done much with it. So if you go to Tools, Global Options, I just want to show you that you can also change things. So I said that I changed my pane layout, which means where my console and my, it's called the source window, my source window are. I put these panels on the bottom because I don't usually look at them. I usually like to see these two side by side. Some people like the console on the left, some people like it on the right. You do you. I like this setup. That's what I do. And so all you do to change it, I could put source here and then console, and that's going to flip my windows. So this may seem trivial right now, especially if you haven't used RStudio before, but kind of making it look how you want it to is part of the fun thing about coding and can make your life a little happier. You can also, I've never changed any of these options. You can, sorry, you can add windows, but I never do that. The other thing I changed was font. So my font is looking, oops, I didn't mean to do that. My font is kind of fancy in that it collapses some of the characters. So it's going to look, you can actually see here, my arrows look like one character. And when I keep that on for teaching, people get confused. So I'm going to show you how I might change that. So you go to Tools and Global Options, Appearance, and I'm going to change my code back to, I forgot what the default one is, maybe Monaco. Let's try that. So it's a little easier. Now you can see arrows are two characters and so on. I might change it back because I like to code in the other one. But you can change the colors, have like a dark background. You can do all kinds of things in RStudio. One thing that also I should mention is because color theme might be different than yours, my errors and warning colors are going to be different. Just don't worry about that. We'll talk about errors and how to deal with that during class. So that's RStudio. There's a little bit more kind of descriptions about what each panel does, but I think it's best to just sort of use them. And then as you have questions about how to use them, let me know. And I will try and pepper in kind of things that are extra, that if you haven't used RStudio and you don't care at all about what your text looks like, just ignore me. But if you do care, hopefully it adds a little bit something to your setup. There's also this website that has useful gifts about customizing RStudio, if you want to look at that. And the other thing about RStudio, which I just shoved under the rug and didn't talk about, but now I will, are RStudio projects. And so I have this question here: how do you eat an elephant? One bite at a time. That's the joke. The thing about RStudio projects is there's a lot going on behind the scenes, and I'm not going to talk about it at first. I will just tell you that when you open RStudio, you should use the project file, and that will force RStudio to open into that folder, the folder where you want to be, and it will set everything up for you so that it works. If you don't open RStudio with a project and you try in some of this code, it might not work. So that's just a heads up. And I will keep mentioning RStudio projects and file management kind of throughout the course to give you an idea of how that's important. But if you're new to R, I know that part can be overwhelming. So again, if you want to ignore this part for now, that's fine, but come back to it later. There's a philosophy about Rstudio projects, and it's the main reason, one of the many reasons that I encourage people to use Rstudio, besides all the like nice tricks that it does for you, is the fact that it has this project thing that regular R, if you were to open the like default R software, doesn't do for you. And it essentially creates an environment that you can use as like a home base. It's where it would create a folder. You create a folder with an R project in it, and that gives you file locations, folder locations that are all tied together to your home directory, basically. And so you will have, when we have data, you'll have maybe a data folder, maybe an output folder. You can have a different file structure that you want, but you will have this project.r, whatever it's called, .rproj file in the home base, essentially. One of the required readings was this from the R for Data Science book on how to create projects. I will try, I think, what time is it? I think we'll talk about that next time probably. So I think just worry about opening this folder right now with this R project. And then we'll talk about opening and like say new projects later once we start dealing with data. But there is information about that. The other thing I want to do is encourage you to go into your global options again. So tools, global options. And there's in the very first pane, general, there's this workspace section. And so I would actually encourage you to unclick this box if it's clicked, so make it empty. And right here where it says save workspace to our data on exit, select never. And what that does is forces you to never save what's in your environment when you leave Rstudio. And I do that, and I encourage people to do that, is because that can give you like a false sense of security. If you're saving output in your environment, you're saving like data, you're uploading data to R, saving it, and then leaving R and then expecting it to be there again, it's not always going to be there again, and you're going to regret that. And so I think that's a good way to just clear your slate every time you close Rstudio and start over. And that's this part where I say, what is real? I think they talk about this here. What is real means that your code and your data files are real. The output is not real unless you save it, right? It's not like if you save it as a Excel file or something like your summary data. You should think of it as a script you can run again and recreate your results. And that's why we save our files. That's why we save our markdown files. And we save things from top to bottom, our data cleaning, our data modeling, our data output, our summary results, all of that stuff should be able to be recreated. And so like we clear our environment, which means clearing all the objects we create during class or during our data analysis. And then we can recreate that again because we have this R script that will do it all for us. Again, we've saved our code. The code is real and the data files are real, and that's it. And so we'll talk about that again and again. I'll bring it up as we learn more about our projects. And the other important thing to get out of the way is that this file that we're using is an R Markdown file. What that means is it's both R code and text, and nice text. Like you can have tables, you can have links. So some of this text, if you haven't seen an R Markdown file before, it's going to look a little funny because you can see I have code, I have text, and then I have links kind of side by side. I have like stars next to it. And that's because it's using what's called the Markdown language. Kind of like when you use Word and you highlight something and you tell it to be bolded. This is another way of telling it to be italicized or bolded. And you can read more about all the different Markdown features, and I will show you them as we go along. And you'll see what it looks like once it's what we call rendered. And so the way you would turn this document, which has both text and down here, this is an example of code. combined is you click, one way to do this is you click the knit button. So up here, you should have a little knitting symbol. And if you click this, if you have the appropriate packages installed, it should render, and so I call it rendering our MRMD into an HTML file. And so now you can see we were down here somewhere, marked down. So you can see that text has now become italicized where the stars were, and the link has become an actual link. The URL went away and you have text that's a hyperlink. So I think a lot of you have used Markdown documents in biostats classes or some other class. So this is going to be old news, but if you're new to it and having trouble like getting things to run or load or just can't figure out what I'm talking about, let me know and I can try and help you a little bit more. There are lots of ways to customize our Markdown. I've added this table of contents, which lets you click around and see the different sections. And the way you do that, I'm going to zoom up here real quick to the very top, is this part of the document. So I completely ignored this at first, but this is what we call the YAML, Y-A-M-L. And that is a section of the document that defines some parts and some options. So this is telling me the title, the author name. When you change this, you should probably change that to your name. When you do your assignment, change it to your name so I know who you are. This is putting in today's date. It's our code, but you could also type in the date. And this is a bunch of HTML options. So there's a lot of different things you can put in there. And at some point I will show you some other options. But I said table of contents, yes. And so I got a table of contents. I'll show you the assignment, which is part 1 assignment. If you look in the files and you can look at the top part here, a lot more simple. I didn't add any options or anything. Just the title, author, date, and then telling it that I want it to be an HTML document. So you don't worry about that, but there are a lot of fun things you can do with this output. Any questions so far about our Markdown, Rstudio? Okay.
Sorry, Jessica, one of the things that you mentioned in the video was that sometimes installing packages can be long, especially if they're a bigger package or you haven't done it in a while. On average, how long should we expect to like stare at a screen scrolling before we get worried in some sort of loop?
That's a good question. And it's funny because I would say one of the only times that's happened is with the tidyverse package. So in the thing I did forget to mention is that I also had this file in here that I asked you in the pre-class materials to use this file to install packages. This package actually contains, I don't know, 20 packages, probably more, and it's installing all of them. I would say normally installing one package at a time, each package should take seconds, not even minutes, just seconds, very quick. There are some that have just a lot of dependencies, which means it needs to install other packages to work. I don't think anything's ever taken more than a couple minutes though. And you should really only do this very rarely. If you want to update things often, that's really good practice, though it can break your code sometimes. But I would say usually it's pretty fast and pretty streamlined in that it recognizes what packages need to be updated and will only update those kind of thing. Yeah, and I'll talk more about what packages do once we need to start using some of them. But the idea really is that there's all of these kind of mini components or packages or libraries, as we call them. And that's in some of this code later. And that contains all the functions we need for certain tasks. And the tidyverse is a big one. These are smaller and should only take a few seconds to install. And I don't think I've ever really gotten stuck in a loop mostly I've waited, and then there's some weird error, and that's disappointing. So trying to remember the last time that happened. Often there's like some dependent package that for some reason doesn't install. And so one tip, I guess, when you're installing packages and you get an error and it says something like, could not install because this package didn't install correctly, and it's a dependency package, is to just install those one at a time until you can get it to work. And that isn't something that will make sense until it's happened to you. So if you're having trouble installing packages, let me know and we can troubleshoot that. And I think I have something about that. So we'll talk about that a little bit more later this evening. But first, for our markdown, if no other questions, just so you know, there are multiple ways to write our code. This R Markdown business is actually quite recent. I don't know, last 6 years, 8 years, I don't know. It's not that, like a lot of statisticians who have been coding a long time don't use Markdown. R Marked is they never learned it, and it's new and it's intimidating. But it's actually really not that hard to do. It's just a slight change in your workflow. So I think it's worth learning about and implementing. I try to use it as much as possible. And the main reason is because it weaves code and text, as I said, puts them all together. So you don't have like this one code script that you need to decipher where the output is going. The output is all going to be right in this document. And the nice thing about Rstudio is the Markdown document is actually a little bit interactive. So in that, I have our code here. You can see it looks different on my screen. It's like in a gray box. And it's also surrounded by these tick marks. I can add a new code chunk, as this is called, or code block, with this little plus C button. And I want to do an R code. Note that there are other options. You could have a Python code block if you wanted. And so that's one way to do it. I actually usually use the keyboard shortcut, which is listed below. I have that somewhere. I think it's Command Option I on a Mac, which means, I don't know. I have it listed down. I'll show you. But it's easy to add those and delete them. And so once you have one and there's code in it, this is code telling me to embed this YouTube video that Ted has a lot of things recorded. And so there's going to be periodic YouTube videos showing up in here. You can watch them if you want. You don't have to. A lot of it's done in our Rstudio cloud, so it's going to look a little different. But you can see that this was the output of that code, and now it is in my document as I'm scrolling through, which is kind of nice because I can go up and see what I've run. And the way, and I didn't mention this, but the way I ran that is I pressed this little play button. There are a lot of different ways to run code. I'll talk about them. But the easiest way right now is to just run each code block by individually and pressing the play button. So this is an example of our code just doing math, our 4 + 5. And you can actually write what we call comments in here. This part is not run because it has a pound sign or a hashtag sign, whatever, in the beginning. That means that it's grayed out and it's not run. It's commented out. This is the R code, this 4 + 5. Note that the code is not space dependent. You can have 4 + 5 all squished together, or you can have spaces in it. Either way, it's going to do the same thing. But R is case dependent. So if you have used SAS, which for some reason is not case dependent, as once we start using variable names, you'll see that case, like uppercase, lowercase, matters. And spelling matters, of course, as I mentioned, it's a common source of errors. This is the keyboard shortcut table. When you render, I'll render it again. When you look at the output, this will look a little bit nicer, but in Markdown, you can make tables pretty easily just with these little pipe symbols, I guess. So there's a full list of keyboard shortcuts. it makes your life a lot easier to not be searching and moving your cursor around to find these buttons. And so when you want to run code, one way to do that is, like I said, to run the whole code chunk, but you don't actually have to. You can go up here and just click. Let's just say I have a bunch of math here, whatever. And I only want to run this last line. What I do is put my cursor here and do Command Enter because I have a Mac, and that only ran the last line. And if I want to run the middle line, Command Enter. You don't need to highlight, you just need to have your cursor there. So each line is a new code. It's not going to run them all together. It's only going to run that line of code. If you're on a Windows computer or Linux, Control Enter is what you want. Like I said, add code chunk for me was Command Option I, but there's also Control Alt I. And if you don't use these, I would recommend like kind of implementing one at a time. You'll be surprised how much more quickly, I guess, you'll be able to code. These things all seem small, but once you start using them, it adds up. And so that's something to keep in mind. There's a whole list of them on this link. There's a Command Shift K is gonna knit my whole R Markdown again. And I've added in this one, which I think is useful to know, which is that when you're in the console, which you can see has my code that I've been running and the output, if you use your up arrow, I can go back and see all the things that I've run. And I use my down arrow, it's kind of scrolling up and down, right? Going down through my history, which, if you care, is in the history tab. So wherever your environment panel is, there's a history, and you can actually look to see the code you ran. I don't actually use the history that much unless I'm really trying to find something specific. I usually just use the up arrow because I know kind of when I ran something. And so some of these will become more useful once we have data and we talk about assigning objects. So come back to this. I really do recommend learning them, even though it seems superfluous. It's helpful. And if you want to see all of the shirts, I don't use this one very often. So Option Shift K, you can see all of them. There are many, 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 many. I don't know all of these, obviously. But so running code, which is the most important thing, play button. There's also a shortcut I do without thinking about it, so I have to look it up. Command Option C or Control Alt C, this one runs the entire code chunk. So this I use all the time, but I don't even look at my fingers, so I forget what it is. Oh wait, did I not copy that right? Run, Control, all right. No, actually, now that I have to think about it, I don't know what it is. I have to fix that. That's not right. But there is one that will run the whole thing. So you can see 994, it ran those 3 lines of code magically. And so throughout class, we'll run code. We'll either run it, most likely run it in the Markdown, but sometimes I'll move over to the console to type in here. But remember, if you're new to R, note that what you type in the console is not saved long-term. So I could assign an object, we'll talk about that in a minute, but I could save a variable or something as a variable or an object in the console, and I may close R and then I will lose that. So something that's not in your R Markdown is not real, as I think of it. It's not saved. So be careful about that. The other thing about R Markdown that I think people struggle with when learning that first is that just because you have code up here, and maybe I should talk about this after signing objects, but just because you've done something up higher up in your document, if you haven't run it yet and you're running through kind of interactively, you can be misled and think that it's automatic and that it's gonna work when you knit it. So if you run into the situation where it's working interactively, but not when you knit something, it's probably because you were running things interactively out of order. So aware that every time you knit the document, it's like a clean slate again. It's reading things in order. You have to define things above where you use them. You have to load packages first before you use those functions. So that's a common mistake I see people do, is like, why isn't this working when it was working when I was typing code? So be aware of that as you're coding. And a question. Oh, yeah, that's a good question. So if there is an error in the code, do you prefer that we add a pound sign or comment it out in our assignments? Yes. Though, one thing that I do is I will add this eval equals false. If I am purposely putting an error in here, or accidentally putting an error in there and I can't figure it out. So that's another way. You can comment it or add this little option. So after the R, you can do a few things. You can name your code chunk. Maybe I'll call this weird error. And then I spelled error wrong, so it's already an error. And you can add options. And this will become more useful when we start making plots and things, and we'll talk about that a lot more. But just know that actually a lot of times here, I'm adding this because I've made an error or I've made code like framework that's not going to run. So that's one way to deal with this. So it's going to keep that code in your document, but it won't run it. So that's a great question. In terms of R, if you haven't used R before, it's not just math, luckily. There are a lot of functions that are built in and that are in packages, which we will load later. So things like round or mean or median, all of that stuff is built in R. And functions take arguments. So here I'm rounding this 3.14. You can see what would happen if I put like a weird letter in here. I got an error. And so that's what an error looks like. In my color scheme, it's orange. It might be a different color, but it says error first. So that's how you know it's an error. You might see sometimes output that looks different colored, but it's not an error. So just be aware of that. So R is going to try to tell you, it's also going to try to help you. Oh, I thought it did. Something popped up earlier. Sometimes if it knows there's an error happening, it's going to alert you. I'll show you a different example later. But the other main thing about functions is that it can take different arguments, and the arguments have names. So one way to know what the arguments are is to search in the help section. So this is kind of the basic way to find help. Click over to the panel that has files and then click on the help tab and then just search for that function. So round. So the built-in functions and then packages that have good documentation will have information about that function. And a lot of the stuff at the beginning just kind of explains what the function does. You'll have like typical usage and default argument values. I'll show more sophisticated examples of that at some point. But the arguments here are listed. So the round function takes a numeric vector. Then there's another argument that's optional actually, because it has a like default setting, no digits. When you round something you don't want, usually you want it rounded to the integer, closest integer, and that's what it's doing. And so there's another option which I'm specifying here as having 1 digit. So I run this, I pressed Command Enter to get the output, and it's 3.1. And so it's rounded it to 1 digit, which is what we would expect. But I'm showing you this mainly because the basic idea that functions have arguments, but also the helping. How do we find help? You can search in the help thing. I never do that because I use the shorthand $round, and that brings me to that document. It's a little faster. There's little backticks around here to kind of tell you, you wouldn't put this in your our markdown. This is more of an interactive thing. And so things that I know I don't want to save for later, I'll just type over here, like quick things, quick code. Let's say mean. I want to look up mean function, and it tells me all about it. It's another kind of simple one, but there are options. And going back to round, the reason that this function here, this usage, we didn't have any names of the arguments is because it's just defaulting to the first argument that it takes, which is the number. That makes sense. But in actuality, all of the arguments are named. And so that first one was called X, which we can see here. And the second one was called digits. And so when you want to define them and you can rearrange the order of the arguments, you would say digits equals 1, comma, X equals whatever your number is. So just know that you can rearrange arguments. And if you want to call them something, the name is what is in the arguments list. The other thing that's nice about Rstudio is you can see me typing here. Let's say I often can't even remember the name of a function. So I'm kind of like, what is it, round? This is an easy one, obviously, but it's showing me everything that starts with row. Round is what I want. So once I start putting in things, it's trying to help me out. It's putting a box that's telling me this is the typical usage. I want put a number here, and I don't have to add digits if I want to, but if I am typing and I can't remember what the next human is, I press tab. So I was typing, I pressed a comma, and I'm thinking, I know there's another argument. I don't know what it's called. For some reason, I'm ignoring this yellow box, or it's not popping up. If you press tab, it's going to show me the arguments there as well. And so digits, if I hover over digits with my mouse, it's telling me it's an integer indicating the number of decimal places. Okay, so cool. I'm going to click on that, and that will give me a nice automatic copy and paste. And let's say I want 1 digit there, and then I do Command Enter or Control Enter, and that gives me the code. So Rstudio, for those of us who are old enough to remember before Rstudio appeared, this is was life-changing. The regular R didn't do this for us. And so I think it really tries to help you, which is wonderful. Sometimes it doesn't work as expected, but most of the time that's a really useful tool to find out what does this function need from me. And the other thing I want to kind of pepper throughout this course is not something I want to overload you with, but just the knowledge that there are a lot of places to get help. Obviously, you don't really need help with the round function, but once you get into more complicated functions, like from different packages that are really hard to use, and even the documentation might be terrible, you might have to search some other option. So turn to Google, but there are actually a lot of different communities online that do really nice help forums, basically. So there's the Stack Overflow, which has been around forever for all kinds of programming questions, but there are specific questions there. Rstudio community is really good, really friendly community. They just want to help you. So don't be afraid to ask questions there, or really just search first, of course, and see if someone's asked your question. Probably someone has. I want to get to other stuff, so I'm going to come back to this and show some examples for some more complicated helping questions. So I'm putting this here for now, but I'm going to come back to it. But first, this is a challenge for you, a 1-minute challenge, because it should be easy. What does the function hist do, and what are our main arguments, and how did you determine this? So maybe put up a little hand once you figured out what the arguments are of hist. And the other thing I'm asking, which is a tricky bonus, is what about the plus sign? Can you find information or like a help document about the plus sign? And that is actually a function, even though it doesn't look like a function. So maybe put up like a thumbs up or a little reaction thingy if you're able to find the help manual for that. It's okay if you can't get the plus one. That one's tricky. Okay, I think most of you did it. The thumbs up disappears too quickly for me to notice. I think most of you got it. So the way you would figure out, I'm not even going to put it here. I'm going to put it over in the console. Hist is I would do a question mark hist. And that pressing enter after that shows me the histogram. And it has a lot of the histogram function. So this function makes histograms and has a lot of different function arguments, breaks, which tell you how close you want your breaks in the histogram, and a lot of different other things. So this is kind of a more typical function. Round is super simplistic. Hist has a lot of arguments. So the thing that I look at here is what is it asking me to fill? I don't need to tell it all of these arguments. They're all defined automatically here. That's what this is saying. The breaks equal Sturges. Freak is defaulted to null. It also tells you this in the text here. So freak defaults to true if and only if breaks are equidistant. So this is a complicated function, but it's trying to describe to the best of the author's abilities what each of these arguments does. And I'm seeing this, X is the only thing that doesn't have a predefined value. And that is what the vector is for your histogram. So you want to give it a theta, and then histogram will give that to me. So let's just say makeup data. That's a histogram of 1 to 100, which this is shorthand in R for 1, 2, 3, 4, 5, 6, 7, all the way to 100. And there's one of each of them. So our histogram is boring. But that is how the default way of using that, that function. The other question I had was the plus sign. So if you do this, what's happening? Nothing's happening. So the question mark plus got me into this weird situation. So to get out of that, I would press escape. And so what you actually have to do is put these backticks around the plus. And now I can see that plus, minus, star, all of that stuff are actually what we think of as operators, are functions that have arguments, but the way that they are computed in R is different than a normal function. You put the X plus Y, you put X on the other side of the plus and the Y on the other side of the plus, and so on. So if something, we will talk about different operators in tidyverse. You can actually use the help manual on those as well. But you just need the backtick situation.
Jessica?
Yeah.
Instead of a backtick, I use quotes.
Yes.
And I think that's just because the way that I was specifying. Does that work all the time? Okay.
Yes. There are situations where quotes do not work and backticks do, and we'll talk about that when we have data.
Okay, cool. Thank you.
But yeah, that's good to work. I actually didn't even realize that works, so that's good to know. Thanks. Good troubleshooting. So, coming up on the last hour, I want to make sure we talk about vectors. So I'm going to briefly go over errors. Let me see how far we've gotten. Yeah, I'll come back to this as well, but just know that you're going to get errors. You're going to get a lot of errors. The most common errors have to do with either not defining an object or misspellings, usually, not having quotes, or not having complete commands. And by that, I mean like closing your parentheses and brackets and all that. Rstudio actually really tries to help you with this. And so this is less common when you're coding in R Markdown. Like if I add a code chunk and if I try to type this out, it closed my parentheses for me. So that's nice. This is more of a console thing. Usually you kind of accidentally delete something. So ours just gonna tell you, for example, this one, hello, is not defined. We haven't said hello means anything. So that just text written there doesn't work. It says object hello not found, which is sort of cryptic, but that really just means you haven't defined it yet. Some functions require quotes around things. In order to install this package, you need to have quotes around it, but you're gonna get an error, dplyr not found. That's because it's not an object that is defined. It needs to be in quotes. So if you're having an error, could not find function, that means probably that you're using a function in a package you haven't loaded yet. We'll talk a bit more about packages next time and loading them and using them, but you need to either define the package that it comes from using this liberdate : Most people don't do this. Most people just load the library. And you'll see at the very top, I've loaded the library using a package called pacman. That's one way to do it. I also could have said library. This is my keyboard is all busted. So them better is the YouTube embedder thing. That's all you need for this one. But later we're going to use a lot more packages. But it's good practice to put it at the top in a code chunk at the top of your markdown. That way, once you use those functions, you don't need to worry about them not being defined, and you know which packages you loaded, and you only need to load them once. So that's a good habit. All right, so I'll talk more about errors kind of each time probably that we run across them, but those are common errors that you might come across. So if something errors, look it up here first, and then otherwise ask me in Slack or ask the community in Slack. Okay, so our another kind of fundamental thing to know is that R uses what we think of as objects. You have to define values to your objects. So whether that's data or just a number or a word or whatever, you call it something. And so like I said, R is case sensitive. So make sure you're paying attention to what you're calling it and exactly what way. But what I would say here is, let's say I'm defining this weight _ kilogram object is 55. I need to run this to establish that. And this operator, the arrow, is saying assign 55 into that value. And notice that this is 2 keystrokes. So the less than sign and the hyphen. You could do equals. That is allowed. Usually when teaching, I try and encourage people not to do this, even though honestly, when I code myself, I tend to use equal sign by habit, though I wish I didn't. And the only reason really for that is because, as you saw up here, when we define, way up here, when we define arguments, we use the equal sign. So it can get confusing having like nested equal signs essentially. And so we try to encourage people to use that assignment vector, this arrow instead. And there is a keyboard shortcut. I think it's like Alt hyphen, if I remember right. It's in one of the keyboard shortcuts up above, but it's still two keystrokes, so do what you want. So just know that I try to be good and use this, but probably in live coding, I'll default equal sign sometimes. But both do the same thing. They assign objects as something else. And so once I've said I want that value to be 55, once I run it again, that's again going to be 55. So I can run it in the R markdown or in the console. Either way, it knows that it's 55 and that it saved it. And I can manipulate it, I can change it, I can multiply it by 2.2 and get 121, get it in pounds. I can then save weight pounds is that. So now I have weight pounds. So one thing I do without thinking often is run part of code within a chunk or even within a line. So this definitely let me know if I'm doing something that doesn't make sense, because I have these habits that instead of just saying I want to recall weight LB, I will highlight it and press Command Enter. which does the same thing. You can see it ran just that, what I highlighted. It told me what weight pound was, 121, and it also told me down here. So you kind of pick up these habits when you start R coding a lot, and how you manipulate excuse me, the code might change depending on how used to R you are. And I just noticed that we've missed our pause time. So let me say real quickly that you can reassign values. That's important. So previously this was 55. If I run this weight kilogram 100, and now I ask what that is, it will give me 100. And so you can change things, save them as new names, but you'll learn kind of eventually how things change, like in terms of relationships to other objects. So we'll see, for instance, if I changed weight kilograms, weight pounds did not change, even though it used weight kilograms earlier. The other thing you can do is remove something. So I've ignored the fact that the environment window is changing. It's now showing us what we've defined, these two numbers, two numeric values. But I can remove that from my environment if I want to. I do this not very often. I very rarely use the remove function, unless it's like a huge data set, which actually is common. But I've removed weight pound. And so now I only have this weight kilogram. And if I try to ask R what weight pound is, it's now going to tell me not found. So this again is the idea that your R code is creating an environment. The environment we are not saving, because I told you to unclick that box in the options. It's not going to be saved when you close Rstudio. But if you have the code to create our weight pound and our weight kilogram, then it's going to be recreated every time you run that code. So that is important to remember. Again, what is real? Your R code, which defines your objects, and your output, which can be recreated each time you run. So there's a little challenge here, and we missed our break. So let us maybe do like a 7-minute challenge break. So you feel free to run this code and then answer these questions, try and figure out what happens to each of these. If it's too easy for you and you don't want to do that, then take an extra long break. So let's come back at like 5:17, and then we'll wrap up a couple extra things before ending. Okay, so coming back, the last little bit of class, I'm going to mostly talk about vectors. And so this little challenge, which if you've used R, is probably too simple, but I just want to get people thinking about how we manipulate the things that we save in R. So R, when you assign something, so here I'm assigning mass is 47.5. Line one at a time by pressing Command Enter. We can see mass now is 47.5. So that would be the answer to number 1. The question number 2 is asking about width. And so I, with my shortcut, would highlight width, press Command Enter, and look at that. And that is 122. And then the other interesting thing when we code is that often we reassign objects and even reassign them based on previous values. So mass, if I want to multiply mass by 2, I might resave that as mass. So just be aware of what you're doing when you're resaving into an old object. Now mass should be 2 times 47.5, which it is, 95. And again, width, I can subtract off 20, resave it as width. And now width is 102. And you can use math with variables. So mass divided by width is going to be equal to mass index. And so if I run that code, mass index is 93%, 0.93. And I could just run everything by Command Option C. I don't know why this isn't working for me. whatever the shortcut is, which I've now forgotten, or this little play button, which, because the only thing I printed, and by printing, I mean like outputting the value of all of these things in this line of code, in these lines of code, was math. So the only output was 47.5, even though it did all the work. So that's another thing to be aware of. You're not going to see the work you're doing unless you call that function or object name. I could have added math index here. And then if I run that chunk of code, now I see the two values, math and math index. And I could have copy and pasted this over here in the console, and I can see math index. But so things to think about with R is, what are you doing, but what are you printing? What are you printing to your output? So be aware of that. Again, you can put comments that won't be run, and you can put comments on the same line. So comment number 1, math, that was not seen by our processor. It just ran this first part of that code. So that's what's going on there. And vectors is the next kind of step up from one value. So here I assigned math as one value, but if we want a vector, which is like a list or a, and I don't want to say list because that means something in R, but kind of like a collection, I guess, of numbers or of other types of things, we would call it a vector. And the way you do that in R is with this C function, which means concatenate or combine. And so I here have made a vector of ages, 50, 55, 60, 65, and I've called it ages. So I'm going to run that, and then I'm going to print or recall that vector name, ages, and I can see R has printed it out like this little 1 in front, which just means it's like a one-dimensional vector. You can ignore that, and it shows me the data as we know it. And vectors is a type of object in R. We're going to learn about data frames next class, and then at some point we'll learn about lists. And so those are all different types of ways R stores information. Vectors are kind of pieces of data frames or data. So you can think of it as individual pieces of data, or just like a collection of names or ages or whatever. And so vectors have kind of components and characteristics, and so we can ask things about it. So length is a function, length of ages. Oops, see now I'm highlighting, did not do what I wanted it to do. I want to run the whole code. If I ask R what the length of ages is, it tells me 4. Another function is class, which is a kind of an R particular function that tells me that it's a numeric vector. That makes sense. There's numbers in my vector. And I'll talk about different types of vectors in a minute. I can ask for the mean of ages, the range of ages. There's so many functions I could be using on ages. And so R knows how to deal with the vector. But that was a vector of numbers. Maybe we want a vector. Yeah, question.
Jessica? Yeah,
yep.
Will R automatically put this in order, or is it just spit back exactly what it was, the way it was input?
That's a good question. It will not. So if I make something out of order, it's still exactly how we input it. Okay. Yeah. There is a function sort, which will sort it for me. But it will exactly output it how you tell it to. And it will keep it that way. Maybe I want to resave ages as the sorted ages, which I can do. And then now ages is my sorted vector. So that is a mini version of things we will be doing with data frames later. Yeah. And you can kind of see that here too, like in the next section, here we have a vector of words or strings or characters. And so this is in quotes because it's text, and we separate them by commas. So this is telling R, I have a vector of 3 organs, and they are lung, prostate, breast. So this isn't ordered in any way. you might guess that if I did want to order it alphabetically, sort is another useful function there. So there's different ways to deal with that, but R can take words and other kinds of data as well. So we're running a little slow, so I don't want to go wait for another challenge, but I will quickly mention this. So like I said, you can ask questions about text vectors just like you can with numeric vectors. So how many values are in organs? So like I said, length of ages worked there. Length of organs also works. 3, we have 3 of them. And class would be, how do we know what type of data this is? And it's telling me it's a character. So that's what R calls text data. And get an overview of organs. So there are many ways to do this. Overview is kind of a vague, I don't even remember what that question was supposed to mean, but you can just like have functions about numeric data. There are kind of text specific functions because it's such a short vector and there's not any like duplicates or anything. There's not really that much interesting. We can talk about it, but we can print it out. There's a function called table in base R, which will tell us there's 1 of each breast, lung, prostate organs. There's many ways to think about this. When we start talking about data, I'll show you many functions that will summarize our data in interesting ways. So that was just kind of a show you examples of types of vectors, but there are other types of vectors. So like I said, we had our numeric vector, which had real or decimal numbers. Sometimes you might have integers. Integers is actually its own type of vector, but we don't really use that very often because it's very specific and not that necessary. Numeric is really just kind of the all-encompassing number vector. If you use other programming languages, sometimes that's called float. It's kind of like that. It's just a numeric vector. Character is the one like organs where we have text data surrounded by quotes, sometimes referred to as strings. So when we talk about manipulating strings, that's what I mean is manipulating text data. And we're going to talk about that later because there's a whole suite of functions dealing with string data. And logical is one that's used sometimes, true and false. You're going to see that in various components. It's often not used as data, but it can be. And then there's others, complex numbers, raw, bytes, and so on. But really the 3 we need to worry about: logic, numeric, character. And this next little challenge is actually just to get you thinking about what R is doing when you try to mix data types. The default situation is that you have data of all of the same type. But if you try to force it to where you have some numbers and some text, for example, what happens here? So we can run this line where I've tried to put 1, 2, 3 in A. Let me just add this here, numchar. You can see now that R has put quotes around everything. And so what R does when it sees mixed numbers and characters is make everything character, because obviously you can't really intuitively change A to a number. You can if you have a reason, but in general, it's easier to turn the numbers into characters. And so that's what happens. And so all of these have mixed, like this is numbers and true. And this is interesting because if we look at num logical, we can see it was 1, 2, 3 true, but now R is saying 1, 2, 3, 1. So if we try to mix Boolean, true, false, and numbers, R is going to turn this into 0 and 1. So let's add false. Now, if we look at num logical, now we have 1 and 0 at the end. So something to be aware of. And then it's actually a useful thing. We might use that as a way to kind of manipulate information. And I'll show examples of that at some point. Logically, what happens here? You can test out all of these. True now becomes a character. Some of these have just interesting behavior. Like if you put 4 in quotes, now R thinks, oh, you want everything to be in quotes, and that's what it does. Which seems odd, but actually, if you have data where all this, for some reason, there was quotes in your data, it can happen, then your vector is going to be all characters, and you might be confused as to why that happens. So just be aware of, if you're getting unexpected behavior, it's probably because there was one element that was just a little bit odd that R tried to fix. And this last one is just a throwback to the errors. I tried to concatenate 2 words or 2 phrases and then hello, but I forgot the quotes. R thinks that this is an object that you're trying to add on to Ola and says, I don't know what that is. You haven't defined it. And so that's why you get an error from this. And again, I mentioned I have eval equals false at the top here, so that when you knit your document, this isn't going to run because I put an error in here. So just be aware of that. If you're looking through the output and you're like, what happened to this challenge? That's because I purposely said that. So I can change this back to true if I comment out the error thing. And so now that will show up in your knitted document. Any questions about R's vector behavior? Another useful thing is you can actually add values to a vector after you've already created it, from the beginning or the end, or well, not really in the middle. I guess you could if you wanted. Usually you just add it to the end. So if we had our original ages was 50, 55, because I sorted it, 57, 60, 65, and I want to add 90, I would concatenate or combine ages with 90 and then resave it as ages. So now ages is 50, etc., and then 90 at the end. So this is just like a mini way to manipulate your data. You can add 30 to the beginning and print it out, and you can see it there. This is a preview of what we'll do with real data when we want to add data, like one value of data to a data frame, a bigger set of data. And then basic R stuff, like how do we want to pull out information from our vectors? This is a way of indexing from the numbers. So let's remember what organs was: lung, prostate, breast. So I want to pull out prostate, which means I want the second item. And so the brackets tell R that I want the second thing or item in organ. So now this is just a vector of length 1 because it has only one item in it. And then there's also this -2, which actually removes prostate. And so also noting, if you're new to R, I'm manipulating this vector, but I'm not saving it as anything. I'm just printing. If I wanted to save this as organs new, for instance, I would rename it and then save it as an object. Otherwise, I can't call it back again. This here isn't saved as anything. It's just printing out my output. It's just coding things. And you can also, this is kind of like nesting vectors and vectors really, because this is a vector of indices of index 1 and 3, and I want the first and the third values, and then I put that inside brackets, and then I say organs 1 and 3 gives me lung and breast. And so when we go through coding, we'll use this shorthand a lot, but once we get into the tidyverse, we'll be using indices less often. Like this is more kind of interactive coding that you'll do, but when we clean data, we're going to rely more along like information in our data to pull out other data pieces and subset and filter and so on. So this is just getting used to our language, but we actually won't use this too often, as you'll see. The other important thing, well, I think probably the last important thing I want to talk about today is missing data. And this is going to become more complicated once we start dealing with data frames, but R is like other software and programming languages, has to deal with missing data in some way. And the way that it does is with this special, not a character, but a symbol, essentially, NA, it's not available, or whatever NA stands for. And that is essentially telling R that there's nothing there, that we are missing that value. So we have heights. I've defined it as 2, 4, 4, NA, and 6. And so if I run this, I've assigned a vector. I'm asking what it is. Notice there's no quotes. It did not interpret this as a string or a character. It interpreted it as a missing value. It's a special kind of value. And so that means that there are special ways to deal with missing data. And so this is a vector of length. All right, this length 5, 1, 2, 3, 4, 5. So when you ask it about length, it's telling you that it has 5 values. One of them just happens to be missing. And so what happens if we run some of our functions that we know work on a numeric? Actually, let me show you that this is indeed numeric. Class heights is numeric. If I try to take the mean, I get this NA, and same with max, NA. And that's because R says by default, I don't know what you want me to do with that NA. Do you want me to remove it? Do you want me to replace it with 0? Or it basically takes the hands-off approach and doesn't tell you the answer. It says you have missing data. So what you would do, which is actually quite clunky, I've always kind of been annoyed by this, but that it's not the default basically, is that you have to tell it this argument na.rm equals rm, which means remove, equals true. So after heights, you add this argument. And what it does is removes all the NA values from the mean calculation and the max calculation. So if you see later on when we run statistical models and you have missing data in your data frame, you will probably run across this a lot. And different functions handle NA differently, but most commonly the way to get rid of them is to add this function, this argument into the function. There are a lot of different functions that have that as a built-in argument. So try that first, but there may be other ways to do it, and we'll talk about that. The one way that you just want to remove, so this is heights again. If I use the function na.omit heights, it's going to print it then without that NA value and then some other attributes which you are going to remove. Not remove, ignore. So NA omit is a function that is useful for vectors and data, which you'll see later. But if you want to run some function on it, you can also maybe save this as something like heights complete and then run the mean on that, or the mean on what I just saved it as is 4 because it's removed that one NA. And so NAs will kind of pop up now and then to bother us. So there are different ways to deal with it, and we'll talk about that for data. But in general, the main thing to know is that this NA is not a character, it's not a number, it's a special value. And when we talk about reading in data, you kind of have to be aware of how your data, like let's say it's an Excel sheet, is coding missing values. And I'll show you some options for dealing with that. Any questions about NAs or missingness? Okay. So I'm trying to decide, we have like 20 minutes left. I think we can do for loops. This is exactly what happened last time, is they kind of ran out of time to go over for loops well. So I think I'm just going to introduce them and then talk about them again next time. because it's a very powerful thing, and also it's the end of class and I don't want everyone to be tired of learning. But let's go, where did my slides go? There it is. All right. So there we go. So up until now, we've done really super basic things, just talking about vectors, missing data, but what do we actually do with that data? So for loops is something that you would learn in a regular programming class, and it's a way to make your coding more efficient. So I showed you what a vector looks like. Later, we'll talk about data frames. But for those of you who have worked with data before, you can think about that in terms of data. But for now, the simple way is just to think about for loops for a vector. And so Ted drew up this little code chunk for us. And this is a very simple for loop. So for loop is what it sounds like, in that we are looping through something. By loop, I mean like iteration or iterating. And for, the for part of it is kind of, it's just been there in programming for so long. What that really means is for this vector, do this. So in this case, our vector that we're iterating around or through is called pets. Notice Ted drew an equal sign, kind of disappointed in him doing that. But if you had an arrow, you could use an arrow. Pets equals the combined vector of dog, cat, and mice. So let's say you have 3 pets. You rank them in terms of your favorite: dog, then cat, then mice. The for loop, and this is a very abstract concept if you haven't run across it before, on why it might be useful, especially with this very simple example, but stay with me. For pet in pets, this is the key definition of iteration. So pets is defined, right? We've defined pets as our vector. Then I'm calling this new thing, this green part, pet. And I'm saying, let's come up with a new name for the individual pieces of pets. And just one pet is called a pet. So I'm going to call this pet. So pet in pets. Pet is like not really an object that you care about. You're not really saving that for later. You're just thinking of this as like a placeholder, like an index variable, a name, something that you're using for the for loop only. So for pet and pets, I'm going to print pet. So inside the for loop is the brackets, which define what we're doing each time we're going through pets. And that is the printed pet. And what does that look like? So the first time, the first pass as we think about it, because we're iterating through pets, we have defined pet as dog. So the for loop says the first thing in that vector is dog. That means pet equals dog, and I'm going to print dog. The second time, the for loop goes to the second item, and that is cat. So now pet equals cat, and now we print cat. And we'll see this in real R code as well. So what do we think the third pet definition is? It's going to be the third item, which is mice. And then it's going to print mice. And I'll come back to that. So going to R, you can see it. I don't know where my things keep going. Okay, so we had it here. Well, not really. Thought I had it in code, but I don't. Here is a different example for using text, I mean numbers, but actually I think I'm just gonna write this. So we said that pets equals C, dog, cat, mice. Okay, so that is our vector that we're iterating across. And then I said for pets in pets, and that is, you put this part in parentheses. This is just like the syntax of R. You can have a space here or not, doesn't matter. And then you put your stuff you want to happen in brackets. And I want to print pets. And so we can see it's printed each value of pets, dog, cat, mice. So it's iterating across this vector pets. It's printing each element one at a time. You can see the same thing in index 1 to 10, where I mentioned this briefly. 1 to 10 is shorthand for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in R. So that's kind of like our pets vector. It's our vector that we're iterating across. And now I've called my placeholder index. And I've also put the curly brackets so that I can have multiple lines of code. Notice it was on the same line here. You could also separate it across multiple lines so you can have more stuff going on in here. And the one thing you do need is the bracket to be on the same line as the for function. Just, well, it's the same line as the parentheses, actually, to be specific, but in general, it's a little bit easier to read if you have it all together here. And one thing that I'm kind of glossing over is that index, I've just made up this word. I think of it as going indices, like an indices of the, or an index or indices of a vector. And I'm going through 1 through 10 and I'm printing them. But it's really just a placeholder. It's not something we want care to think about after we're done with the for loop. It changes each time we go through it. So index is 1, then 2, then 3, then 4, and we can see that here in the output. Actually, did I run this whole thing? I don't think I did. There we go. So we can see that it's output the 1, 2, 3 each time it's gone through the index, through the 1 through 10. It's not really a variable that's meant to be used outside that for loop, but it actually is saved. So just know that now if I call index, it's the last value of that for loop. It's 10, the last value of our vector. But it's not really, it's really just a convenience placeholder for that loop. And I could call this whatever I want. I have the habit of calling the indices letters, like II, which is not a really very good variable name. It's not descriptive or anything, but it doesn't matter. I could call this anything I want, really, as long as I know what the name is that I'm iterating through. So these are the visuals that Ted just did. And then one more thing, a little more sophisticated thing is going through the pets again. For pet and pets, this time I'm defining something inside my for loop. You can see now every time I go through the vector pets, I am going to call my pet. The function paste combines the word Jessica's and pet, and then I'm going to print that. So what does this look like? Let's just run it. So you can see that pet iterated through dog, cat, and mouse, and then pasted these texts together: Jessica's dog, Jessica's cat, Jessica's mouse, and that's what it printed. And then because I've defined it, it actually is saved as something, my pet. And it's, again, the last thing that I called it. So the last thing that I saved it as, which was the last index of our vector. So are there questions? This is like a very loose overview of for loops. We'll use them again later, but are there any questions so far about the concept? Cool. So you might wonder why are we even doing this? Like printing out something each time you go through a vector. And the printing part isn't that useful. It's actually what happens once you save your work, really. So this is kind of, this is a lot more tricky than anything we've come up across. So the idea is that I want to save this Jessica's dog, Jessica's cat, Jessica's mouse as a vector. I want the output to be something I'm going to use again. I showed you that my pet is just the last one. It's not all the output. So I want to save my work. So what I do is I first create an empty vector that I'm going to put everything in. So the way you create an empty vector is use C, but with nothing in it. So all my pets, if I run just this line, all my pets, I'll put it over in the console, when I output that, when I print it, it's saying it's null. And that's another special, kind of a special character, special meaning. NA, null is a null value, it's empty. Different than NA. It's used differently. It's not that it's missing, it's that it was purposefully empty. And I'll probably bring up that nuance a lot more in later, more complicated code. But for now, it's an empty vector. And again, I'm doing the exact same thing for pet in pets. I'm going to paste Jessica's pet together, but I want to add them into that empty vector. So all my pets is now the combined concatenation of all my pets and my pets. And so what does this look like? If I run this and then output all my pets at the end, is what I'm doing here. All my pets is now a vector, character vector. It has length 3. I can print it. It's exactly what you want. Jessica's dog, Jessica's cat, Jessica's mouse. I didn't mention what these numbers mean. When we just saw that one previously, it usually just means there's just one item because that's as far as it goes, but it's trying to index, trying to give you like an index number for the vector. You can see this is the third one. It's useful if you have really long vectors and you're trying to pull out one, but I tend to just ignore those numbers. So I didn't mention it. But so what it was getting rid of this previously, let's go look at this output. So this was the output where I just printed it. Jessica's dog, Jessica's cat, Jessica's mouse, and you see 1, 1, 1. And that's because it's printing one thing each time. It's not saving it. But if we run this, it's not printing anything. I removed the print statements. I don't have print my pet anymore, right? It's not printing each time, but it is saving it as a vector. And so when I call it at the end, it's going to print the 3 length vector. And if I actually got rid of this and just ran it, there would be no output because I'm not printing anything. I'm not calling back anything. I can add this to a different code chunk and now see that I've saved it as something. And so this is actually, I did this already, but we can look at the length and the classes of it if we want, the character vector. And so there is a homework question, which is basically very similar to this. Just getting used to making an empty vector, putting something inside a for loop, which basically means inside the brackets, and iterating across a vector. So pets, note that pets is a vector defined above. Very important. It's already something we know. It's up here somewhere, pets. And so in our Markdown, if I had started this and not run this code and then tried to run this code, it would tell me it doesn't know what pets is and would say pets not found. And so you had to be careful to run the defining R code first. So this is the part I'll talk about next time. You don't need this part for the homework and it's a little bit more complicated. So we're running out of time and I don't want to rush anything, but I do want to go over this again because it's something that's useful. And later, we'll learn about other ways of iteration. So for loop is the most kind of basic way to iterate across vectors or across data frames, for instance. But R has a lot of very powerful functions that can do it even more automatically. And so we'll get to those like week 3 or 4 or something eventually. So we'll ramp this up real quick. And one thing I will talk about this again is that there actually is a shorter way of doing what we just did. Regarding the pets, I'll show you the other example next week. Paste, I showed that function when I was pasting Jessica with pet, but I could also have pasted Jessica's pets total, all of the vector. So a lot of these functions in R can handle vectors. So the for loop was not necessary. It was more of a educational statement, but it is possible to just do this with one line, just so you know. And again, let's see, we have a few minutes left, but I don't want to go too late. So I'm just going to let you know that, again, there is the post-class survey. Here's the link. Please click on that. I am working in the Dropbox folder right now. So if you tried to download the Dropbox folder again, you would get all this extra. You'd get my mini RMD as well if you want it. And I'll double check the assignment to make sure it makes sense from what we talked about, but the assignment is in here. You should be able to just knit this right now. So this is the assignment. What you will do is fill in inside these code chunks. Right now they're blank. And then so there's four parts, and please let me know if you have questions. You shouldn't really need any packages for this, so hopefully it shall just run easily without installing any new packages. Next week we'll need some tidyverse stuff. And I think that's about it. Let me know, are there, which portion are responsible for the homework? Yeah, okay, so more specifically, you'll see in the markdown, there are instructions. You don't need to change any of this text. All that you really need to do is just change the code or add in code. So this is giving you instructions like create an object with this name. And so you'll do that inside the code. Underneath these comments, which kind of describe the question. In this question here, again, it's just code. I think in later assignments, there'll probably be like, you can change the text with answers, but in this first one, it's all just code inside the code chunk. And so they're all kind of standalone too. So you could start with part 2 and then just work in that code chunk if you wanted. Then yeah, 3 is also separate. So again, underneath the comments, basically 2 parts for each question. The for loop, I left completely blank, but it should be very similar to the pets example, but with numeric data. And if you have trouble, definitely ask me a question. I'm happy to give hints and all of that anytime. On Slack is probably the easiest way to ask me or ask any of us. And so here, if you want to submit the homework, what you would do is knit it and then submit the HTML file. You can do PDF if you want. I have it on HTML right now. HTML is just easier, so I would recommend that. And what you'll see is, I don't know why there are 2. That's weird. You should only, wow, that's bizarre. You should only see 1 of these, and I don't know why it's like acting like it's a double. But when you go to the folder that this is in, you can like drag and drop that into Sakai. And so this is the file. I'll open this in the web browser just so you can see. This is what the file looks like. It's just a one file, and you can submit that to Sakai. If you're having trouble rendering anything, you could either, like we were talking about earlier, comment it out and like kind of write a note to me of this isn't working, I can't figure it out. Or if you're really having trouble, maybe with later stuff, just submit the RMD file and we can try to make the most of it. I think this one should be, you shouldn't have too much trouble with rendering. So once we get into weird functions and things, like things can get a little more difficult. Any other questions? In case there's an error. Yeah, so if there's an error, you can add a comment, the hashtag #, and comment it out, and maybe write a little comment to me saying this isn't working and I don't know why. That is one way to do it. Or you can do the eval equals false. But it's a good idea to give me a heads up of where you're having an error, just so I know you know why it's not working, or that it's not working. Yeah, any other questions? All right. Well, I will see you all next week. I will let you know what I decide about office hours, but in the meantime, if you want to meet with me, definitely let me know. And I hope you all have a good week. It's weird only teaching once a week. I'm not used to this, so it'll be a while till I see you. Thanks, everyone.
Thank you.